Okay, we're going to go ahead and begin, and I want to welcome everybody and thank you for joining today's webinar, Optimizing Your Alarm Response. This webinar is co-hosted by ISA and Maverick Technologies. I'm Michaela Cooper, I'm with ISA, and I'll be hosting today's webinar. But before we get started, I'd like to review just a few housekeeping items to let you know how you can participate in today's webinar. First, in regards to the question and answer session, we do have a Q&A session at the end of the webinar. And to submit your questions, simply type them into the Q&A chat box that's on the right-hand side of your screen. And we ask that you do not use the chat toolbox for the Q&A session. If you have miscellaneous questions for me, technical questions, then just submit those into the chat box. But the Q&A session, please use the Q&A chat box. If you have any direct questions for the presenter, their email address will be given at the end of the webinar for you to contact them directly. Second, for those of you who just joined, please make sure that you are on mute. If you would like to see the phone and audio broadcast instructions again, please refer to the confirmation email that I sent to you today. Or if you go to the top left-hand side of your WebEx screen, you'll see a tab labeled Event Info, and some of those connection instructions are included there as well. So as a reminder, just make sure you are on mute if you have dialed in through your phone lines. Additionally, once this webinar closes, a survey should pop up in your browser. Just take a few minutes to fill out the survey. It's fairly short. We just want to know what your experience was like today in our webinar so we can better improve our webinars. Okay, I think that takes care of our housekeeping matters. To get started, I'd like to introduce our presenter. This is Greg. He's responsible for managing the Enterprise Integration Professional Services Group at Maverick Technologies, which specializes in production execution, work process management, and manufacturing intelligence systems. Since spending 5 years in the U.S. Navy, his career has been focused on manufacturing system software development. Highlights include 3 years at Deloitte Consulting as a senior consultant, where he was part of the Technical Integration Group, responsible for system design for SAP, Oracle, and middleware applications. 9 years at General Electric as product manager of the Prophecy SOA workflow software product, where he was responsible for the design and development of next-generation manufacturing software platform for the Prophecy product line, which led to 2 patents for work process management system designs, and a year and a half in a senior consultant role at Tata Consultancy Services, where he was leading the development teams for Prophecy SOA workflow-based systems. He received his BS and MS in computer science at the University of Alabama. Welcome, Greg. Now we'd like to pass it off to Greg so he can go over our agenda and kick off this webinar.
Okay. Can you hear me okay, Michaela?
Yes, perfectly. Thanks.
Good. All right. And let me share my display here. All right. To get started, I'm just going to go over a quick agenda. First of all, we'll talk a little bit about the alarm management standards and also discuss business impact of not properly managing alarms. We're going to move into the current technologies for alarm response procedures. We will talk about the electronic alarm response procedures, a method that you can use to electronically respond to alarms through mobile devices and HMIs and so on. We'll look briefly at the physical architecture that it takes to set up a system like this. And then what I'll do is I'll go into a live demonstration where I'll just real briefly show you the typical capabilities that you would want to see in this type of system. Okay, so to get started here, it's been a number of years ago, and ISA and the industry in general has recognized a lot of problems with responding to alarms. And there had to be a method to really rationalize those alarms or bring those alarms down to something that's reasonable. I'm not an alarm management expert, but I am an expert in the response procedure area. But I've been involved with alarm management projects and gone through the life cycle, and it is amazing to me how many alarms some people have, like in the process industries and a refinery. I was working with a refinery last week, and they started their alarm management life cycle with 6,000 alarms that could be active during any day. And when they got through their rationalization phase, they were down to about 220. And even at that, they thought that that was a little bit high. So there is a very serious problem. I've experienced this over the years where I've seen some significant impact to production and brand and so on as a result of not responding to alarms properly. What you'll see here, where I'm going to be very focused, is in this operational phase. And in this phase is where you have your alarm response procedures. And really what I want to talk about today is taking a look at the evolution and the advancement of the alarm response procedures. We'll look at the current technologies, and then I'll introduce you to what I consider the state-of-the-art technology in this area. As I had previously stated, I have seen alarms that have been not managed correctly, especially during alarm floods and upsets. And during that time, it's very overwhelming as to the number of alarms that you have to look at and trying to sort through the ones that are important. And in a lot of cases, as you see here, all of these instances that you see here were caused by not properly handling alarms. The alarms were available, and it was identifying the situation, but the operators were just overwhelmed by them. So the question is, even though you go through an alarm management, let's say you went through an alarm management program and you still reduced your alarms, there's still a set of alarms that are very critical to operations, and that the timing, response time to those is very critical. Some of them are regulatory, where, for example, EPA, if you have a type of alarm that is environmental, there's set guidelines for when you got to respond to that and how you got to respond to that. And I just looked the other day at the EPA incident list and the fines, and a lot of the fines that I saw there were due to just not responding to the EPA regulations within a timely manner. So how can we use technology today to identify and bring up front to the operator the corrective action that's necessary for an alarm, okay? How do we cut the cycle time, the end-to-end cycle time down? And on top of that, how do we coordinate the efforts of many roles within a facility to complete that end-to-end cycle? And those are the types of things that we'll talk about. Now, if you look at the current technologies that are available, if you look over in the upper left over here, you see guidance for preparing SOPs. It's hard to believe, and I don't know what the percentage is. I saw a reference to over 80% of the production facilities out there today are still using paper SOPs. Now, I think I don't believe that. I could say probably more like 60 in my experience, but still 60% is pretty high. And now the advancement in SOPs has made a jump to where people are still writing their SOPs in Microsoft Word, but at least they're publishing them to an intranet, or they're putting them in a document management system of some type that makes it easier for operators and operational staff to reference those documents when they need to. The problem with it is, as you guys know, I read through SOPs all the time, and heck, I gotta just sit down and think about it and stay very focused about reading the SOPs so that I don't miss something, right? And they're usually really wordy. So the recommended action is spelled out here, probable cause, and then any design information that was given during the rationalization program. Now, this is a huge step up. You notice a few things here. Number one, this is going to be on the control system. It's going to pop up in front of you on your HMI or some type of display, and it's tied directly into the active system. You know, you can see the alarm state's been active for a minute. And also, it's looking at the time to respond and how much you've got. So this is a huge step up. The only problem that I see with this type of system is that it's okay if the alarm response that's necessary is localized to the control system, okay? Because this is in front of the operator, and there may be instructions in here that you got to call the environmental and safety people, and you got to call maintenance, and you got to do this, and you got to do that. But that operator has to do all that stuff. Okay, so that slows down the response time. And then after you notify all these people, how do you coordinate those efforts? You know, and how do you have visibility into where you're at with all these steps? So even though it's a huge step forward, there still is deficiencies in this type of system. Now, as technology's moved up, when I was at GE, we developed what we called an industrial workflow system. And essentially what that is step-by-step instructions. It's a general technology, okay? So a workflow is, you know, you got step 1, step 2, step 3, and so on. But the huge advantage to it is not only can you connect this to your control system, it can reside outside of the control system or within it, but it can coordinate the different roles that are necessary to complete the corrective action. So what you see over here is really what we call a task definition. And this particular task definition responds to a distillation column high-level alarm. And these are the steps that are necessary to get it done. And what you do is you configure this within the system here. And then what you do is through OPC or a native driver, you can connect the system to your DCS or to your PLC, and whenever the condition happens, then it will instance this particular workflow. So the advantages are you got multiple roles, you can touch real-time data, you have access to structured data such as SQL, you've got access to document management systems, all of these things, and you're putting all the instructions in front of the person to get the work done as quickly as possible, and I'll show you some examples of that. If you look at an electronic response system, I think these are the major components that should be part of it, okay? Number one, promoting the ISA 95 standard. I really believe that your plant model should be defined and managed around the ISA 95 standard. And that ISA 95 standard takes form of the equipment model for your plant definition. So what this does is this allows us to create context for the data items that are coming in that indicate the alarms, and then other equipment information. Location context is very important when it comes to the responses, as far as directing you and keeping historical information about where some of these actions were performed. The next thing that's very important within a system like this is personnel context. And this, again, can be represented within the ISA 95 personnel model. So the personnel context does a lot for you. Number one, it controls security. It also, you can identify roles that a person is qualified for, such as an operator, maintenance, QA tech, production supervision, QA manager, and so on and so forth. When you have those types of roles defined, when you start executing alarm responses, you can designate what role should be able to perform that particular step. Okay, so the personnel context is important, not only for the execution, but also for the historical record of who did what, where, and when. Now, what I'm going to show you is there's different types of alarm responses, and you can create templates for these. So a very important part of a system to keep the maintenance down on these types of systems is where you can create templates of response instructions. Another major component of this is the dispatcher. What you will see here is in this, what I call alarm response server, and this usually takes the form of a VMware image running on a VM server. What happens is that you'll hook your OPC A&E data or HDA data, or your native driver will connect through this. And what you'll have is a dispatcher. And essentially what it's doing is that when you define these alarm responses, you can then marry that response to a trigger. And that trigger is coming from your connection to your DCS or SCADA system or whatever. And then this dispatcher will listen for those. And then once it hears this particular alarm, so there could be 1,000 alarms go through here within a minute, but maybe there's only one of them that you're interested in. And the dispatcher will listen for that, hear it, and then it will instance the operator response instructions, okay? And then once these instructions are instanced, they'll show up on what I typically call a task client, just a general term for it. And that is a client that will allow the instructions to be presented to the user and the user to interact with those instructions. And then the last thing, which is even half as important as all of this, is the historical record of the execution of your alarm response. So who did what, when, where did they do it, how long did it take, you know, start time, end time, and so on, and any comments that were entered and messaging that was sent and things like that. So the historical record is very important, not only for regulatory compliance, but also for just improvement of the alarm response or the processes themselves. Okay, so that is that's pretty much a logical software architecture, but now you look at, okay, so how do you apply this on top of a control system? And what you see here is there's many ways that you can do this. These task clients, I think some of the requirements that you would be looking for in a system like this is you got to be able to embed that task client into an existing HMI. Okay, how do you do that? You know, through ActiveX or a web page or something like that. I think it should also be web-based, you know, where you don't have to install software on a particular computer or mobile device to use the task client. And then even what's more important today is mobility, is how can we take that task client and put it on your PDA, basically your pads, your iPads, and your phones. So the client itself is very key to this. Typically, what you'll see is that you can layer this stuff on top of existing platforms. The other thing that's important, I just noted over here that there's an alarm response server, and in this day, I mean, all of this stuff ends up being virtualized almost. So there is a number of servers you can interact with. It can plug into the same backbone so that data from all these different types of servers can feed into the alarm response server as possibly trigger mechanisms for the alarm response. Okay. Okay, so what I'm going to do here is I'm just going to give you an idea of what a task client looks like and what it does. And then what I'll do is I'll jump over into a live system and we'll take a look at that. So this is a task client that I'm referring to. I like to think of it like Microsoft Outlook almost, because what you see here is this area in here, you could think of this as like your inbox. So anytime an alarm response would be triggered, it would show up in your inbox. Now, the only way that it's going to show up in your inbox is if you're qualified to perform any of the steps that are necessary to complete that corrective action. So in this case, all you see is one showing up in the inbox. Now, once the operator or user would select that, then you'll see a list of steps. Now, these lists of steps have associated with them what you call work instructions. Not only work instructions, but in a number of systems that are available, not only can you put text in here, but you could take and embed HMI SCADA screens inside of the instruction. You could put photographs in here with your instructions, videos, link to manuals and drawings and things like that. And the idea is to bring everything in front of the user so that they don't have to go outside of the screen to execute the corrective action or the alarm response. Okay, so what I'll do is I'll jump over right now into a live system. And what I'm going to show you, I'm going to skip over the benefits real quick. What I'm going to show you is this. I just have a refining example. I have other examples in there, but I just wanted to step through this with you so you could understand what's going to happen. What you see here with this type of system is that we had a high distillation column limit that was hit. As soon as we received that trigger, then we instanced the alarm response, and immediately the first step behind the scenes is it sends notifications to operations supervisor and safety personnel, and so that's all automatic. And the type of notifications you can send is completely varied, and with the technologies we have, it goes all over the spectrum. We could send text messages, we can send email. I've even done text to voice over radio. So there's a lot of different ways that you can do this. So the notifications are sent, safety lock has been triggered, and the next step is to shut down the feed pump. And so I'm not going to read all this to you, but basically this is the high-level steps that are necessary to complete this alarm response. So I'm going to sneak over here and just hope everything is going well. I'm on a remote server here. So distillation high column, distillation column high level is in the inbox. So you can see here what I have is I've got the task client that we just talked about. And down here I have April is logged in here, and April happens to be an operator. And so what she's done is she saw this alarm response, she selected it, and now what she has in front of her are the steps that are necessary to complete this. Now, what's important to note here is that if you look at the steps, it indicates the role that's to perform that particular step. So I've got operator, 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 maintenance, operator. Now you notice maintenance is grayed out. What's really important in these types of systems is that based on role that someone can only perform the work that they're allowed to perform. So you can see here that we're grayed out, so April could get down to this step and she can't do anymore, right? She's going to have to wait for that maintenance person to complete that step, and then it comes back to an operator. The other thing that's interesting about systems like this, because it's role-based, anybody can log in and assume responsibility for the step that's qualified. So in some cases, you could even run in parallel. The way that I've explained this so far is that these steps, I guess the assumption you would make is they're sequential, but that's not necessarily true. You can, when you define this alarm response, you can designate some of these steps as running in parallel, and then you can merge them back to sequential, and then you can go back to parallel and so on. So it's not restricted to, hey, do step 1, do step 2, do step 3. So in some cases, an operator, there could be multiple operators that are taking responsibility for different parts of this if it's allowed to be run in parallel. So what you see here is that the first step is selected, and right here is something very interesting too, is that within an electronic alarm response system, you can embed things that are just like within an HMI. In this case, there's a button that's been embedded in here to where you could click on this and it can communicate through OPC or the native driver back to the control system and actually shut the pump down. Now, a lot of people say to me, oh, geez, I don't want somebody doing that. And there are a lot of situations where you do not want somebody to directly do that outside of the control system or HMI or the panel. But I just want you to understand that the technology is available to where you can start bringing things in front of the operator or whoever's working on this step so that they don't have to leave here. So technically, there's very little limitation as to what you can embed anymore inside of a work instruction. So not only are you receiving instructions what to do, heck, you could have gauges in here. You could have different types of switches, just like it's an HMI display. So it's just something to think about. The other thing that is common, like I said before, is having linked documents. So this is where I've seen electrical drawings and all kinds of stuff, reference to SOPs that are on a document management system you see here, that even though we're executing a alarm response in the workflow, the original SOP that it was taken from, you could still reference it if you'd like to. But imagine having 2, 3, 10 different links in here that are referencing different documents that can help you with the step. So this is step dependent. As you move through different steps, you would have different linked documents. Okay, so the next step usually is the confirmation or the indication of the type of work that was done. Something that we've done is we also include the ability to send messages directly while you're executing. This could be text messages. It could be notifications of any type. And basically, you're selecting groups of people, like the maintenance people. You can type in a message and comments, and it'll send it. But when you indicate what actions are taken in this case, it will then complete the step and save that information historically. What I think is very important about these types of systems is that all data that is shooting back and forth should be recorded. And what I mean by that is if I'm sending an email to somebody for this step, I want the option to where I could historically save those email messages along with the record of the execution of this particular step in this alarm response. So those are things that I think are really important when you try to take a look at it later and see, what's happened. You can enter comments in here and things like that. And once you hit the submit button, then it completes this step and it moves on to the next step, and you have the work instructions. And I'm not going to go through all this detail with you, but what I'm going to do is just move through here really quickly, and you can see the various types of work instructions that you can display. And then we get down to the point where this maintenance person has to do something. April can't do anything. So I have another client open here, and you notice Terry Smith is logged in here, and you can see that all these other steps are not available to Terry, but this maintenance step. And Terry could come in here, enter information, submit it. Whoops, I got to tell it what to do, huh? Okay, and now that went away for Terry, right? It's gone out of his inbox because he only had one step that he could complete in there. So I'll go back to April, and we'll go to the distillation, and you can see that it's all been completed. She's going to complete the last step in the process here, and you'll notice that it'll go away, and then she can get to work on some of her other things that she has to do. So that gives you an idea of, that was a very simple example. Right here is a food and beverage example. I'm not going to go into that today, but just to give you an idea, I mean, heck, you look at this, there's been some debris that was found within a vision system. This alarm response could actually query the vision system, pull out the image, embed it into the work instruction, okay? And then you've got all these roles that are involved. You got QA tech, you got material handlers that need to quarantine some of the product. You got the operator again, and then in the end, purchasing gets notified, and a nonconformance process typically starts. Like, let's say that I've been in these bottling filling lines where, heck, in bottles I've seen worms, pieces of glass. I even saw a salamander one time. So you just never know what gets in these bottles. So this is a kind of alarm response that would make sure that you don't get a salamander in your next bottle of beer. So this gives you an idea of what a task client typically would do. But now compare this, you guys just remember, to the alarm help system within your typical DCS today. It's hugely different, right? Because you're managing and coordinating multiple roles outside of the system. Just briefly, what I'm going to talk about here is the historical side of things. Any one of these systems should give you the ability to look and drill down on historical data. And in this case, you got a number of filters up here that you can work to narrow this data down. And it gives you some pretty interesting information, like over that period of time, I had this alarm happen 91 times. Mean time to repair was 2 hours and 13 minutes. Mean time between failures, 44 minutes, and so on and so forth. And then I could drill down. There's the 91 instances during that time period. And then I can even drill right down to the specific instance. And if this only has one step in it, but if this had multiple steps, you would see all those steps and then comments. And there's a lot more data that you can mine out of this. Let's say alarm trigger analysis. So not so much the response information, but what about the alarm triggers that are coming in? So this is what we're getting from OPC. And over that period of time, this is what we're looking at. What about looking at nuisance alarms? Most systems have nuisance alarms where you can say, you know, in 30 seconds, if you see 2 instances of this, add it to my list. And this is just a small portion of the type of data that you should historically have access to. Okay, so what I'm going to do is I'm going to jump back here. I'll talk about the benefits real quick, and then we'll go into a Q&A. So personally, while I was at GE, I had a team and we did deployments on this type of technology at GE. And I looked at the list of benefits that we saw, and this is kind of a partial list, but I thought it was the most important. Number one, visibility across the entire facility. So imagine your supervisor being able to look at his phone and look across the plant and see all the alarm responses that are currently active and who's working on them and when they last worked on it and where they worked on it. I mean, that's huge. Think about shift change, the discussions that happen at shift change, and this type of visibility would help a lot. Again, managing across different roles, speed response. The brewery example that I had just shown you, we cut that response time in half because we were managing all the different roles properly and bringing people together. And in a brewery, I mean, you don't make money unless you ship product. So if your packaging area is down, you're losing big time revenue. Minimizing training time. I've seen this a lot, is that you get your second and your third shift people, operators that may have a little bit of struggle with some alarm responses, and they will get this type of help, and it really does decrease the training time. And some of these other things, I think, and then a real major benefit was compliance. So insurance of that you're meeting regulatory compliance standards and reporting standards. Okay, so I guess what I'll do is Michaela, I'll stop there, and we can open this up for questions.
Great. Thank you, Greg.
Yep.
All right, I'm just going to change to one of the last slides here. Okay, there we go. All right, so now we've entered into the Q&A portion of this webinar. If you haven't had a chance to enter your questions yet, go ahead. We've opened up the Q&A box. It's down there at the bottom of your WebEx screen. Simply type them into the Q&A box, and we'll go through them as they come in. Let me pull this up. Okay, we received a question earlier.
Yeah, I see this one here.
And they asked, they would like to understand the role of alarm response server in the architecture.
The alarm response server, you know, what it's doing, initially when I showed you the logical software architecture, that dispatcher is really what's running on the server. And so that's a piece of software that has to be installed and running somewhere. Now I've installed this in an HMI SCADA instance. I've done that before, but I really recommend that it's independent. And again, it's typically a VM image where all the software that's necessary to run the system is within that image. And then the only thing that you're bringing in and out of there is really the OPC data that's going in and going out, and then the reporting data also.
Okay. Our next question comes in from John. He asks about the reporting tool. Was that a custom application or part of another SCADA system software?
It's really what it is that, like at Maverick, what we do is that we'll take a general off-the-shelf product, which this happens to be Prophecy Workflow, and we'll create a template that sets on top of it. And the reporting side of what you just saw was a template that we developed. So when we go implement this at a customer's place, that's a SQL Server reporting service template, or report, excuse me, and it's available through a web page, or it can be embedded within a web control. So it's really not another SCADA system. It's really reading off the database where we've collected all those alarm triggers. Okay, so it's the alarm response database. And those nuisance alarms, by the way, are those that have made it through to our system. Okay, so usually an HMI SCADA system, they have their own nuisance alarm, same with the DCS. But we try to look at nuisance alarms also. So they are separate systems.
Okay, next question. How would you prioritize alarms during alarm flood?
Basically what happens here is that you'll have an alarm flood, and that dispatcher, you got to remember, all we're doing is listening for those that have an alarm response tied to it. So if we got an alarm flood, and let's say there was 500-600 alarms, and we had alarm response that were tied to 2 or 3 of those, then it would activate those alarm responses. So that's how it sifts through or filters through all of that noise. So the only thing that you'll see, and it'll come up in front of you, are those alarm responses that are necessary to be done. So, you know, you don't have to sort through a flood and make your way through the important ones. So that is how we approach it, is we basically filter it based on the alarm response that's been tied to a specific alarm.
Okay, and you may have already answered this, but is this commercial software or internally developed? Yeah,
and again, what you folks will find is that there's many different software packages out there that could do this. This particular one, like I said, is Prophecy Workflow, the GE product, and all we're doing is putting context around a general tool. So we've, you know, obviously given it the alarm response context.
Okay, next question. What about redundancy in the case of hardware OPC communications lost?
Yeah, and that's really important. These systems, there's a number of ways to do this, but even within this system, this particular one, there is redundancy. But in a lot of cases, what we're relying on is not only the SCADA and its connections. There's a lot of software out there that's available for redundancy. And if you want to send, is there a way for them to send me specific questions later? Michaela?
Yes, we've got your email address up here on this slide. So if they want to send you direct questions, they can send them to you via email.
Yeah, there's a lot of lot of discussion to be had with that, but almost in all cases, there's some type of redundant system set up for OPC in these installs.
Okay. Next question. Based on your experience, who's usually responsible for developing and adjusting for specific cases?
That is all over the place. The people that are, here's the other thing that I have to say is that I put these in to where there is no alarm management program that's been performed, but yet the company has some very serious regulatory issues that they got to watch for. So what I see happen a lot is there's somebody responsible, like for the control system or for operations. It's either the one or the two that will take responsibility for defining the alarm responses. Now, an alarm management program, you know, there's designated engineering people or operational people that are designated within that life cycle that I had shown you to take responsibility for that, the alarm response definition and then the long-term management of it. And that really is what that life cycle is all about. So it's varying. Like I see controls engineering people and I see operations people. It's kind of, I think, kind of split from what I've seen.
All right, next question. How do we need to configure alarms in case of high performance graphics especially?
I think in that case, I would have a problem answering that accurately. So we have specialists in high performance graphics, and if, again, you send me that question, I'll have our people get back to you on that. How do you?
Okay.
How
do we address intrusion by a hacker that will result in an unwanted response?
That's a good question. And, you know, every company has their standards for cybersecurity and how they enforce it. But, you know, the software in itself has to have a certain degree of compliance with some cybersecurity standards. And this particular GE product does. But heck, you have, you know, you're at the mercy of what your corporate policy is and the programs that they have available. And it's a tough one. So there isn't anything inherent within the system that can prevent that, because usually it happens well above, you know, the intrusion happens well above where this system's at, and it will make its way down. So we definitely would not have a first line of defense there.
Okay, next question. If we have multiple DCS systems from different OEMs, how can it be integrated for analysts into the same software module?
Okay, what ends up happening here is, like within this case here, is that you can connect to multiple OPC servers, or if there's a native driver available for the system, you can connect to those. So what's happening here is I could have many different control systems from many different vendors acting as a source for these alarm triggers. So in effect, it would consolidate dissimilar systems through an OPC connection or a native connection. So there is no problem hooking to multiple sources and bringing it in. And whenever that data is coming in, it identifies where it came from. So if you were to do some analysis on alarm triggers and nuisance alarms coming in, it would identify the system, the particular system it come in on. Historically, that data is saved. I know it is. So no problem there.
Okay. I don't know if I see any more questions. Somebody asked if it's expensive to install a SCADA system.
To install this, it's, you know, I don't want to get into anything commercial, but you'd be surprised how inexpensive it is. It is not like putting an MES system in or something like that. It's very inexpensive. And the different vendors out there, you know, the pricing of this is going to be all over the place. But if you want to know more about it, just email me and I can give you some details.
Okay, great. Well, thanks to everybody who participated in today's Q&A session. I don't think I see any more questions coming in, so we're going to go ahead and wrap up.
Okay.
All right. And like I mentioned at the beginning of this webinar, once you close out of this webinar, there'll be a survey that pops up. Please fill it out. Let us know what your experience is like so that way we can better improve our webinars. And if you did miss any portion of this webinar, I know the audio may have cut out for some of you. Just know that we recorded it, and I'll be emailing you all a link to the recording either sometime today or tomorrow, so that way you can watch the recording or share it with your colleagues, as well as some additional information. We hope you acquired useful information, and we hope to see you again in one of our future webinars. Thank you.